Nestled close to the Sun, Mercury, the smallest planet in our solar system, hides a wealth of enigmas. For years, this tiny, scorching world misled us. But recent advancements in space exploration have revealed astonishing discoveries. Spacecraft have even hinted at the presence of diamonds on this fiery planet. And that's just the beginning. Mercury's internal structure is perplexing, larger and more unusual than anticipated. What accounts for these differences, and what other secrets lie beneath its surface? Mercury has fascinated astronomers and space enthusiasts for generations. Its mysterious landscape remained largely concealed until significant advancements in space exploration began to uncover its layers. The quest to understand Mercury's secrets began with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe launched in 2004. Mariner 10 was the first spacecraft to approach Mercury, providing our initial close-up views of this elusive planet. During its flybys, it captured images revealing a surface marked by craters and unusual ridges, reminiscent of our Moon. This mission uncovered Mercury's rugged, heavily cratered exterior, a surprisingly strong magnetic field, and a core larger than scientists had expected, challenging previous assumptions about the planet's composition. The Messenger mission, which launched 31 years after Mariner 10, significantly enhanced our understanding of Mercury. Unlike its predecessor, Messenger was designed to orbit Mercury, allowing for a more comprehensive examination of the planet. Over its mission, Messenger captured an impressive 200,000 images, unveiling previously unseen regions of Mercury. One of Messenger's most intriguing discoveries was the detection of unusually high levels of calcium and magnesium on the planet's darker side, raising questions about the processes that could lead to such concentrations. Additionally, the probe found that Mercury's magnetic field was unexpectedly strong in its northern regions, differing from other planets. These findings prompted scientists to rethink Mercury's internal structure and formation. While most planets, like Earth, generate magnetic fields through the movement of liquid iron in their cores, Mercury's unique internal composition results in different magnetic behavior. What truly distinguishes Mercury is not just its craters and ridges, but the extreme conditions on its surface. Temperatures can soar to a blistering 430 degrees Celsius, 806 degrees Fahrenheit, during the day, only to plummet to a frigid minus 180 degrees Celsius, minus 292 degrees Fahrenheit, at night. This dramatic temperature fluctuation is due to Mercury's thin exosphere, which fails to retain heat. Despite these harsh conditions, recent studies have revealed surprising features on Mercury's surface. In 2012, Messenger data indicated evidence of volcanic activity, including pyroclastic deposits from explosive eruptions, challenging the long-held belief that Mercury was geologically inactive. Even more astonishing, in 2020, scientists announced the discovery of water ice in some of Mercury's polar craters. These permanently shadowed regions are cold enough to preserve water ice, even on a planet so close to the Sun. This finding has sparked new questions about the potential for simple forms of life on Mercury. Could extremophiles, similar to those found in Earth's harsh environments, exist in these icy refuges? The latest mission to Mercury, Bepi Colombo, launched in 2018 as a collaboration between the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive in 2025. This mission promises to provide even more detailed insights into Mercury's surface, including its chemical composition and geological history. From its unexpectedly strong magnetic field to the presence of water ice, Mercury continues to surprise us. But here's a mind-boggling question. How can a planet so close to the Sun have a year shorter than its day? When we think of planets, we typically envision them rotating on their axes once a day and orbiting the Sun over the course of a year. However, Mercury defies this norm in a remarkable way. On this small, sun-baked world, a year is actually shorter than a day. To break it down, Mercury takes just 88 Earth days to complete one orbit around the Sun, making its year significantly shorter than ours. But here's the twist. A single day on Mercury, one full rotation on its axis, takes a staggering 176 Earth days. This means that on Mercury, a year is only half as long as a day. This peculiar situation leads to some truly bizarre phenomena. If you were standing on Mercury's surface, you would witness the sun rising, gradually growing larger in the sky as it moves across the heavens. At one point, the sun would appear to pause, then move backward for a while before resuming its original path. This strange motion occurs because Mercury's rotation cannot keep pace with its rapid orbit. So why does Mercury rotate so slowly? Scientists believe it's due to tidal locking. Over billions of years, the sun's gravitational pull has slowed Mercury's rotation. However, unlike our moon, which is completely tidally locked to Earth, Mercury is in a 3-to-2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the sun. The effects of this unusual day-night cycle on Mercury's surface are extreme. The side facing the sun endures intense heat for months, while the night side remains in frigid darkness for an equally long duration, resulting in some of the most extreme temperature variations in the solar system. Speaking of Mercury's atmosphere, or lack thereof, it's worth noting that the thin atmosphere it does possess is called an exosphere. This incredibly tenuous layer of gases is constantly being lost to space and replenished through various processes, including solar wind, radioactive decay, and micrometeorite impacts. Recent observations have revealed surprising components in Mercury's exosphere. In 2020, researchers using messenger data discovered that Mercury's exosphere contains more water vapor than previously thought. This water vapor is believed to form when hydrogen from the solar wind interacts with oxygen in Mercury's surface rocks. Another fascinating aspect of Mercury's short year and long day is its impact on the planet's magnetic field. Despite its small size and slow rotation, Mercury possesses a global magnetic field, which surprised scientists upon its discovery. Recent studies suggest that this magnetic field is generated by a unique dynamo effect in its liquid metal core, influenced by the planet's peculiar orbital and rotational characteristics. This magnetic field, while much weaker than Earth's, plays a crucial role in shielding Mercury's surface from the harsh solar wind. Without it, the solar wind would strip away what little atmosphere Mercury has at an even faster rate. The combination of Mercury's rapid orbit and slow rotation also leads to intriguing observational possibilities. Certain points on Mercury's surface, known as hot poles, experience moments when the sun appears to stand still in the sky. These hot poles endure the most extreme heat on the planet, while areas near Mercury's poles remain in perpetual shadow, where scientists have found evidence of water ice. But how does ice persist on a planet so close to the sun? Thanks to Mercury's unique orbit and rotation, the permanently shadowed craters near its poles never receive direct sunlight, keeping them incredibly cold even as nearby regions bake under the sun's heat. This discovery has prompted scientists to ponder, could there be other volatile substances, like organic compounds, preserved in these cold traps? Mercury's short year and long day also complicate our study of the planet. Because Mercury orbits the sun so quickly, spacecraft face challenges in reaching it. They must execute complex maneuvers, including multiple flybys of Venus and Mercury itself, to slow down enough to enter orbit. The Bepi-Colombo mission, currently en route to Mercury, will utilize these gravitational assists to gradually adjust its speed and trajectory. Launched in 2018, the spacecraft won't enter orbit until 2025, after completing 9 planetary flybys. Once in orbit, Bepi-Colombo will face another challenge related to Mercury's unusual day-night cycle. The spacecraft must carefully manage its exposure to the intense heat on Mercury's dayside while also maintaining power during the long, cold nights. This delicate balance is crucial for the mission's success and underscores the extreme conditions created by Mercury's unique rotation and orbit. Recent computer simulations have provided new insights into how Mercury ended up with its current rotation rate. These models suggest that Mercury may have once rotated much faster, but was slowed down by the combined effects of the Sun's gravity and impacts from large asteroids or comets. This research not only enhances our understanding of Mercury's history, but also sheds light on how other planets in the solar system may have evolved. As we continue to study Mercury, new questions arise. How does the planet's core remain partially liquid despite the long nights and extreme cold? What role does Mercury's unusual orbit play in shaping its geology? These inquiries remind us that even within our own solar system, many mysteries remain to be uncovered. Mercury's unique characteristics challenge our understanding of planetary formation and evolution, pushing us to expand our theories and explore new possibilities. So, what other astonishing secrets might Mercury be concealing beneath its cratered surface? Recent discoveries and ongoing missions are revealing that Mercury's subsurface holds secrets just as fascinating as its visible features. One of the most interesting aspects of Mercury's hidden depths is its core structure. Unlike Earth, which has a solid inner core surrounded by a liquid outer core, Mercury's core is primarily liquid, with a solid inner portion. This unusual core composition was confirmed by NASA's MESSENGER mission, which used subtle variations in Mercury's gravitational field to map its internal structure. The solid inner core of Mercury is estimated to be about 1,260 miles, 2,000 kilometers wide, making up nearly half of Mercury's entire core. This is proportionally much larger than Earth's inner core, which only accounts for about 20% of our planet's core volume. The size and state of Mercury's core play a crucial role in generating its magnetic field, which, while much weaker than Earth's, is still surprisingly strong for such a small planet. Beneath Mercury's crust lies a mantle that is thinner than previously thought. Recent studies suggest that Mercury's mantle might be only about 260 miles, 420 kilometers, thick compared to Earth's mantle, which is about 1,800 miles, 2,900 kilometers, thick. This thin mantle has implications for Mercury's geological activity and heat distribution. One of the most exciting discoveries about Mercury's subsurface came in 2012 when MESSENGER detected evidence of ancient volcanic activity. The spacecraft found unusual shallow depressions called hollows that seem to have formed when volatile elements sublimated from the surface. These hollows suggest that Mercury's interior once contained more volatile elements than scientists previously believed. In 2020, researchers using data from MESSENGER made another groundbreaking discovery about Mercury's subsurface. They found evidence of a vast underground reservoir of magma that existed in Mercury's distant past. This ancient magma ocean likely played a crucial role in shaping Mercury's surface and internal structure. The presence of this ancient magma ocean could explain some of Mercury's unique surface features, such as the vast smooth plains that cover much of its northern hemisphere. These plains, known as the northern volcanic plains, are thought to be the result of massive lava flows that occurred early in Mercury's history. But perhaps the most jaw-dropping discovery about Mercury's subsurface came in 2022. Researchers analyzing MESSENGER data found evidence of nitrogen trapped beneath Mercury's surface. This nitrogen could be the remnant of an ancient atmosphere that was driven underground by the intense heat and solar radiation bombarding the planet. The presence of subsurface nitrogen raises intriguing questions about Mercury's past. Could the planet have once had a more substantial atmosphere? If so, what implications might this have for its early climate and potential habitability? Another fascinating aspect of Mercury's hidden depths is the presence of water ice in permanently shadowed craters near its poles. While this ice is technically on the surface, it's hidden from direct view and protected by the extreme cold in these regions. Recent studies have suggested that some of this ice might be relatively fresh, perhaps deposited by comets or asteroids within the last tens of millions of years. In addition to water ice, these polar craters also contain dark deposits that scientists believe could be organic compounds. These compounds, which appear to be more volatile than water ice, might be remnants of comets or asteroids that impacted Mercury. The preservation of these organic materials in Mercury's subsurface provides a unique opportunity to study the distribution of organic compounds in the inner solar system. Mercury's subsurface also holds clues to its tectonic history. Unlike Earth, Mercury doesn't have plate tectonics, but it does show evidence of significant contraction as the planet cooled over time. This contraction has resulted in numerous thrust faults, where one section of crust has been pushed up over another. These faults, which can be several kilometers high, provide a window into Mercury's subsurface composition and geological history. Recent analysis of these thrust faults has revealed something unexpected. Mercury may still be tectonically active today. A study published in 2019 found small landforms called grabens associated with some of Mercury's largest faults. These grabens, which are essentially small valleys formed by the extension of the crust, appear to be geologically young, suggesting that Mercury's crust is still shifting and settling. One of the most mysterious features of Mercury's subsurface is the planet's magnetic field. Unlike Earth's magnetic field, which is generated by the motion of molten iron in its outer core, Mercury's magnetic field is thought to be produced by a different mechanism. Some scientists propose that it might be generated by a dynamo effect in a thin outer layer of liquid metal surrounding a solid inner core. Another intriguing aspect of Mercury's hidden depths is the possibility of subsurface faults and fractures that could provide pathways for heat and potentially even fluids to move through the planet's crust. While Mercury's surface is bone dry today, some scientists speculate that there might be pockets of liquid water deep beneath the surface, kept liquid by residual heat from the planet's core. The idea of subsurface water on Mercury might seem far-fetched, but similar phenomena have been observed on other seemingly inhospitable worlds in our solar system. For instance, Jupiter's moon Europa and Saturn's moon Enceladus both have subsurface oceans beneath their icy crusts. While Mercury's environment is very different, the possibility of subsurface water cannot be entirely dismissed. As we continue to explore Mercury's hidden depths, new questions arise. How has Mercury's internal structure evolved over time? Could there be other volatile elements or compounds trapped beneath its surface? And perhaps most intriguingly, what might Mercury's subsurface tell us about the early history of our solar system and the processes that shape the inner planets? These questions underscore the importance of continued exploration of Mercury. Each new discovery about its hidden depths not only enhances our understanding of this fascinating world, but also provides valuable insights into planetary formation and evolution throughout the solar system. As we look forward to future missions and discoveries, one thing is clear. Mercury, despite its small size and proximity to the Sun, still has many secrets to reveal. Its hidden depths hold clues to its past and potentially to the history of our entire solar system. What a journey, right? Share your thoughts on what we might uncover on Mercury in the near future. Could it be precious gems, or perhaps even signs of extraterrestrial life? If you enjoyed this video, be sure to hit that like button and subscribe to the channel so you never miss any updates. Thanks for watching, and we'll see you in the next one.